Hello. As promised, here I am with this second part of the video, just to make sure that the other one was not too long. I believe we ended with me distinguishing between a pumping and an artesian well. That was in this diagram. And the next diagram basically emphasizes some of the things we talked about already, but it also brings these two new terms, aquifer and aquitard. An aquifer simply means a body of rock with water that can hold water, either because it's porous or it has joints or fractures. Whereas an aquitard is rock that doesn't allow water to go through because it doesn't have fractures. It either doesn't have pores or it has pores that are not connected, as we saw earlier with the distinction between porosity and permeability. This diagram again emphasizes all of that. So we have three wells here. This well goes through, see a lot of joints or fractures in the rock all over the place. The well to the left here goes through a few fractures, and so the well will have water. The well to the right also goes through some fractures, even though it's a shallow well, just because it goes through fractures, it has water. The well in the middle is dry because even though it's deeper than the well to the right, it doesn't have water because it did not go through any of the fractures. By the way, this line is not a fracture line, but this well is going to be a dry well. So that is what that talks about. And another term that I just want, that I mentioned earlier, that I'd like for us to just drill down a little bit is the idea of an unconfined aquifer. So if this is a rock layer that holds water, we call it an aquifer. In this case, it is unconfined because it's exposed to the atmosphere. So it rains and the water falls in the ground and infiltrates and becomes part of groundwater. And this is your saturated rock. And so this is an aquifer. And the recharge is the entire surface area through which water could come into the ground, either directly from precipitation or sometimes it could be if from streams or lakes if the water table drops. In this case, the groundwater is feeding the lakes and streams. The other thing I'd like for us to look at is the difference between confined and unconfined aquifers. So this aquifer here, this region where rain, you have precipitation and then water infiltrates into the ground, is called unconfined because it's exposed, the aquifer is exposed to the atmosphere. This rock layer below here contains water as well. This small one here is impermeable. This is an aquitard or aquiclude. And this aquifer that is sandwiched between this aquiclude and this aquiclude is known as a confined aquifer. Okay, so this is a confined aquifer, and this bed and this bed are the confining beds. These two beds are confining this aquifer. This is called confined aquifer. This one is also a confined aquifer because it's between this confining bed and this confining bed, or this aquitard or aquiclude and this aquitard or aquiclude. Okay, so there are three terms here that mean the same thing: confining bed, aquiclude, and aquitard. They all talk about the same thing, as opposed to aquifer, which is the bed that holds water. We've seen all of this already, but this is just another view. And the area, so we call this recharge area, and this is discharge because when it rains, the water flows downhill into a stream, and in some cases, springs from groundwater will flow into the water, into the stream, and runs off. And so we call that the discharge area. You've seen this top diagram before where you have a dry well here because of the water table dropping, so not much to say there now there. But what I just want to do is emphasize this artesian well. This is another picture that better defines a confined aquifer. See this region here. And this is an aquitard or aquiclude, same here. Now, how does this aquifer get its water? The recharge area is not this entire surface, as in this case at the top diagram. In the top diagram, whenever it rains, the water just flows through all the way into this aquifer. In this case, there's an aquitard here, so it's not going to come into this aquifer. The way it gets its water is from this region here. So this is its area of recharge because this rock is exposed out here. And where is the water table for this rock, this aquifer? This is the water table. The water table is the highest point of the water in the aquifer. Okay, so the water table is not here. This is just the boundary between an aquitard and the aquifer. The water table is right here. Now, if you drill a well in this confined aquifer, you have what is called an artesian well. And why is it called an artesian well? Well, it's considered a well under pressure because the water column from the water table here all the way here puts a lot of pressure. The weight of the water puts a lot of pressure so that when you drill, it's going to push the water up the well and it will go up in the air to the height of the water table. Okay, the projected water table here. So if you are fortunate to have this kind of well, all you need to do is cap it and then just put a pump at the top, and whenever you need the water, you open it, the water will come gushing out because it's under pressure, natural pressure from the water column pushing it up. As opposed to any of these wells up top here, where if to get water you need to maybe tie a bucket to a rope, throw the bucket in here, fill it, and then pull it out. Or you you submerge a pump in here that will pump the water out to you and then you use it. So this is a pumping well, this one, and then below here is an artesian well which produces based on its natural pressure. So the other thing I just want us to then reflect on, having seen what happens to water on the ground, is what we are doing to the environment. You have a plane here that is spraying probably pesticides, could be fertilizer, all good because, you know, they help with our crop yield. But what is that doing to groundwater? When it rains, some of it, because plants definitely don't use all of it, it seeps into the ground, and you've just seen how groundwater moves and how you drill wells and what kind of things could happen. Or you can have chemical waste being disposed improperly, as in this diagram. Or you can have a flood that washes all kinds of nasty stuff into streams. So to the left here, you have all kinds of potential hazards that get into our groundwater. We saw this diagram earlier, and I put it here just so that you can think about what happens if that chemical disposal site was somewhere here. Think about it. When it rains, it will wash it off into the groundwater, and this groundwater then feeds this stream, and the stream carries it to different areas, and people use it for all kinds of things, maybe for domestic use or to try and do other kinds of things. It's not good. So that is not a good thing in terms of pollution. In some cases, the pollutant could be your gas station. Whenever you are pumping gas, what you may or may not know is that there's a large tank on the ground. You usually see those big tanker trucks around midnight, 1 or 2 a.m. filling those tanks. They come when there are fewer cars along in the way. Now, almost every one of these around the country develops a leak at some point, and the regulations monitoring them are loose. And if there is a leakage, it creates this plume, which if you were living here and you drilled a well down here, well, you know what you're going to be getting. So drilling a well for domestic use close to a gas station is never an advisable idea. What if there's a chemical plant in the area that is releasing some stuff that gets into groundwater? Or let's just say to the left here you have a landfill. Okay, you keep dumping all your waste here, but when it rains, some of that stuff gets washed into the ground and it forms this large pool that can go for miles. And you drill your well and you're drilling into stuff that is coming from miles away from you. And that's why we all need to be each other's neighbor to kind of protect the environment, because where you are, you don't know what is upstream. And if you drill a well, it's good to have the water tested to make sure that you've not received water that has received some contamination. Now, the good news is that water gets filtered as it moves through the ground, but sometimes it's not filtered well enough by the time it gets to your own location. I put this here just to emphasize the aquifer, the artesian well again. So you have here an impermeable rock, as you can see labeled here, and you have a permeable rock here, or aquifer. And so this is a confined aquifer. And an artesian well, again, the water, when you drill, it will come up to the height of the water table. This is the water table for this rock. The recharge area is somewhere to the right here. Okay, and it comes through, and it fills the rock all the way here. The last thing I'd like for us to talk about is salt water in. Sorry about the typo there. It's supposed to be intrusion, not interosion. Saltwater intrusion. Here you have the ocean and land. When it rains, the water infiltrates, gets into the ground, and some of it flows into the ocean. Some of the ocean water also gets into the ground. And when the fresh water from land meets with the salt water, the fresh water stays on top because it's less dense. And so you just have this separation here, right here, with the salt water circulating the ground and the fresh water just flowing. Now, what happens if somebody drilled a well here? Well, let's see the second diagram here. If you drill a well, as you pump, you start creating a cone of depression, which is what is forming here. Now, when you create that cone of depression, the overhead pressure from the groundwater is lower here. And when it's low, then you have your salt water beginning to move to fill that zone of low pressure. And as that salt water bulges up, it forms what is known as a cone of ascension. So it's the opposite kind of cone. So you have a cone of depression here, and then you have a cone of ascension here. When the cone of ascension meets the cone of depression, then you have salt water in your well, and that is never a good thing. And when you do that, then you have what is called saltwater intrusion. And this is a phenomenon in the coastline where you have pollution caused by saltwater getting into your water well. So that's it for today, and that was the homework, and you have all of that. And I look forward to talking to you in the next time. Thank you. Bye.